Manager in charge of the Falcon Small Launch Vehicle Demonstration Program, which was one that the Operationally Responsive Space Office of the Air Force had. And before that, he was production manager to implement the world's largest self-reacting friction stir welding capability up at NASA Michoud in New Orleans. Let's see, and he previously served on the Crew Return Vehicle Structures and Mechanisms Subsystem Lead for Lockheed Martin. He was the IPT lead for the development of the metal liquid hydrogen tank for NASA's X-33 program. And he's got a BS degree in mechanical engineering from the University of New Orleans. And please join me in welcoming Jules Schneider.
Okay. To where we are, and some of you may know all this, so if you do, I apologize, but just bear with me. So after the Columbia accident, there was an investigation board that was run by, I believe, an Admiral Guyman, I believe, who put out the report that recommended that NASA complete the construction of the space station program with the shuttle, but then retire the shuttle system. So NASA took them up on that. George Bush was the president. Mike Griffin was the NASA administrator at the time. So the Columbia Accident Investigation Board recommendation didn't say what the next system should be. It just said that NASA should retire the shuttle and then go develop the next system. So the Mike Griffin NASA community went off and did some studies, and they came out with what was known as Constellation. So Constellation consisted of Orion as the people carrier, and it had launch vehicle. It had Ares-1, which was going to launch Orion. It was a single 5-segment solid with a liquid upper stage. It had Ares-5, which was a heavy lift vehicle. It also had a couple of other elements that the development hadn't started yet. It had a lunar lander called Altair. It had an Earth departure stage, etc. So when the Obama administration came into office, they commissioned a study that was run by a guy named Norm Augustine to go look at the viability and was Constellation the right thing to do. Their recommendation was that while technically sound, Constellation, you couldn't afford it. There was not enough money to go execute Constellation. So the Obama administration zeroed out funding for Constellation, I forget what year that was, and effectively canceled all of it. So then Congress got involved in a lot of back and forth between the administration and Congress, and the question was, if we're not going to do Constellation, what are we going to do? So what came out of that was what's called exploration, and that's what you see here. So Orion actually survived into exploration. It was the only element of Constellation that did survive into exploration. The main reason, I mean, there was probably a lot of reasons, not the least of which was probably political, but Orion technically met all of the requirements that the spacecraft that was going to carry the astronauts for exploration had. So basically it was, Orion met all those requirements already. It was already in Orion's requirements set as part of Constellation. The main difference, and I'll show you this on another chart, is that in exploration, Orion is just really the beyond low Earth orbit vehicle. The low Earth orbit piece of NASA's human space flight is going to be handled by what you've probably heard as commercial. I'll show you that in a second. So Orion survived and came out of Constellation into exploration. Ares, the launch vehicles, did not survive. So they needed a new launch vehicle. So that's now SLS, or the Space Launch System, that's being run out of the Marshall Space Flight Center, and that's what you see here. There's a 70 metric ton version, and then that will evolve into a 130 metric ton, I believe, capability. And then the third piece of exploration is the ground systems development and operation. So it's the piece of exploration that's actually run out of the Kennedy Space Center to get all of the ground systems ready to go to launch SLS and Orion. By the way, Orion is run out of the Johnson Space Center. So even though we're building it here at KSC, it's actually a JSC program. So JSC runs Orion, KSC runs ground systems, and Marshall, MSFC, runs SLS. So that's how we got to the exploration architecture. Just a little background. So just to kind of reiterate where Orion is going to operate. So you see the space station in LEO, in low Earth orbit, and then you'll notice down at the bottom here on the left you see commercial cargo. That's already happening, right? So SpaceX has already flown several missions that has delivered cargo to the space station. The one on the right there is Orbital. They actually did launch just recently, and I think they berthed to the space station recently as well. So both of those commercial cargo suppliers are actually operating now. The box just to the right of that says commercial crew. So that's the administration and Administrator Bolden's program to get astronauts back to the space station, not using Russian rockets, right, using American rockets. The proposals, there's three bidders there, Boeing, SpaceX, and Sierra Nevada Corporation. All three of those proposals were delivered to NASA, I believe in February this month or maybe late January, and there's a down select. They would like to down select to two, but they won't say. It depends on how much money they have. I'm guessing it'll probably be one. They'll down select, I believe, in August of this year or September, and that person will be put on contract to develop crew to the space station. So Orion is on the right at the bottom over there, along with SLS, and its mission now is beyond low Earth orbit. So the moon, asteroid, eventually interplanetary to Mars. The SLS that Orion will go up on initially is, like I said, a 70 metric ton version, and then eventually that'll get evolved into a 130 metric ton version. Originally, as part of Constellation, Orion had the space station as a destination, but when we went to this architecture, we are not designed now to go to space station. I think it could, but that's not part of our requirement set. So, we don't have that. There is a special, you probably heard over in the other room, there's a special Russian docking hatch that you need to dock the space station that we don't have anymore because we don't need it. Okay? So, there are three major elements of Orion: the launch abort system, and I'll talk about each of these just briefly, the crew module, which is the capsule, and then the service module. The launch abort system is designed to save the crew either on the pad or during ascent, should there be a problem either on the pad or with the launch vehicle during ascent. There was a launch abort system on the Apollo rocket. This one's quite a bit larger. The abort motor on this rocket is 500,000 pounds of thrust. It fires for about 2 seconds to bring the capsule up. If it's on the pad, it brings it to a mile, altitude of a mile. If it's on the launch vehicle, it has to get a mile away from the launch vehicle. So it has to outrun the launch vehicle, which is why 500,000 pounds for 2 seconds. We did actually fly a pad abort, and I'll show you that in a second. We've already flown a pad abort, and there's a plan to fly an ascent abort here in the next few years. I'll show you that in a second. The crew module, obviously, is where the folks live and work, and then the service module is an unpressurized power, propulsion, environmental control, life support systems. The service module gets jettisoned just like Apollo right before re-entry, and the capsule comes back in. The launch abort system jettisons itself once you've got a successful ascent and you put Orion into orbit. So go ahead.
How many Gs would be put on the astronauts if they...
15. 15. Okay. 15 Gs is if the abort motor fires. Obviously, it's a bad day if you have to fire the abort motor, so the object there is just to survive. You probably won't be very comfortable, but at least you will survive. Okay?
Conscious either.
You may not be. You may have heard that ESA, the Europeans, are involved in Orion now. This is a fairly recent development. So the part of Orion that ESA is going to provide is the propulsion module that's part of the service module. So in this picture, you'll see right here, this part of the service module is what ESA will provide going forward for missions EM-1 and beyond, and I'll show you that in a second. So this is really the main test flights associated with the DDT&E for Orion, culminating in EM-2, which is the first crewed mission. You'll see EFT-1 on the left. That's the one that we're building right now. We fly it in September of this year, so not very far away. We're actually working 24 hours a day, 7 days a week in the ONC building to get ready for EFT-1. That's going to fly on a Delta IV Heavy. There's actually a little model of it in the room right over here if you want to go take a look at it, which is pretty interesting. It's the only time that'll happen because starting with EM-1, we're going to be flying on SLS, which is the rocket that NASA's developing for this system. The reason we're flying EFT-1 on a Delta IV is, so if you go back to my story about how Orion survived out of Constellation, when we got into exploration, we were very far along in the development of Orion because we had started in 2006. We had passed CDR, and we had EFT-1 hardware in the loop, in the supply chain. Because Ares did not survive and SLS was kind of a back to the drawing board, they weren't going to have an SLS until 17 at the earliest. So we approached NASA and said we can be prepared to fly Orion in 14 if you would let us go get a launch vehicle. And we worked with ULA and convinced NASA that it would be of value to fly earlier. NASA did allow us to go work with ULA, get a Delta IV Heavy, get on their manifest, and put the EFT-1 flight test together. We have to fly EM-1 in 17. You'll see that that'll be on an SLS. Then to the right, we have to fly an ascent abort to prove the launch abort system works during ascent. We did a pad abort, but before we can put people on Orion, we have to fly that ascent abort. And then you see 2021 for EM-2. Most of the pace of this development program is governed by funding. We'd like to go a lot faster, but it's all about how much money NASA has to pump into both Orion, SLS, and the ground systems project. There is some discussion about possibly moving AA2 to the left of EM-1, and because if you can fly AA2, say in 17, then you can put people on EM-1. Yes, sir.
The Rocketeer community has requests for AA2. We know that they're not required, but we'd really appreciate if you would put fins on it.
Yeah, I'm not sure.
I make them clear.
I say modified Peacekeeper. I think that's what the launch vehicle is going to be for AA2. I'm not quite sure. I think that's what it's going to be.
But when you're in discussions, just tell them fins would be fins.
Okay.
Even if they fall off.
Well, other part, if you're going to be traditional, call it the Lijo 3.
Yeah,
There you go.
that's actually probably more appropriate, right?
Is it going to be a boilerplate or is it going to be a full Orion?
No, in fact, that's a good question. What we're going to do is we're going to take EFT-1 after it comes back, and we're going to recondition it for AA2. So we're going to fly AA2 CM crew module will be EFT-1. Okay. Some milestones this year leading up to EFT-1. So if you look in the upper row in the middle, you see that's the Delta IV booster at the Decatur facility. The first one of those actually will show up here at KSC, I believe, this week coming. You see the MCC in the upper right in Houston getting validated in April. We deliver the vehicle out of the ONC building to the ground ops processing flow in June. In July, we integrate the launch abort system, and then we launch in September.
That's a funny looking Delta IV.
Yeah, that's Ares 1, right?
Yeah.
So what does the EFT-1 mission look like? It is a 4-hour mission. It will launch out of Launch Complex 37 on Cape Canaveral side. It'll do 1 lap in LEO. It'll then have a burn to go into an elliptical orbit. It'll go out 3,600 nautical miles and then come back and land off the coast of Southern California. It will be the farthest we have sent a spacecraft out and returned it since the Apollo days. I have a video coming up here. Here we go. So this is a quick video of the EFT-1 mission. There's no sound associated with this one. So that's us launching on a Delta IV Heavy, again out of Launch Complex 37. booster separation, and then Orion separates. We're going to use the upper stage of the Delta IV as our on-orbit propulsion system for EFT-1. There are a set of fairings on the service module that separate. That's us burning into that elliptical orbit. You'll come back, you'll see the crew module separate. The crew module has a hydrazine monopropellant RCS system. That's fires there to get us lined up for re-entry. And there's a series of parachute deployments. That right there is the forward bay cover jettison event, and it has some drogue chutes, pilot chutes, drogue chutes, and then the main chutes to slow us down to our landing velocity. Okay. There's been quite a bit of testing ongoing for Orion. You can see some of the stuff on the left and some of the pictures, and I think I have quite a few slides in here. I'm just going to tick through fairly quickly, showing you some of that work. Here's the pad abort 1. This was actually flown out of White Sands a couple of years ago. It wants to grab that bottom. Trying to get to the yeah.
It's like whack-a-mole. Knock it down one place,
It
pops
wants
up
to get
somewhere.
to them.
Check for hydrazine links.
Let's try it. No?
Hey.
I really want to show you that.
3, 2, 1, launch.
The launch abort system has 3 different solid motors. It's got an abort motor, it's got the jettison motor, and then it's got an attitude control motor. You see the attitude control motor firing up at the top. It's got little hot gas valves that basically reorient the capsule for parachute deployment. And you see the jettison motor fires to cut the LAS loose. That's the forward bay cover jettison. And you see a series of chutes. So this is the lawn dart coming down. This was a very successful test flight.
Cool.
How close was the lawn dart?
I don't know how far downstream. They did find it. It was fairly small at the point. It was compressed quite a bit. Obviously, if we abort off the pad here, we would land in the ocean off the coast of KSC. That was out at White Sands. So I think we've done a good job politically positioning Orion. We're in 48 states. People are developing hardware for the Orion program. All 10 NASA centers are involved. The good thing is, though, for people here locally, Lockheed Martin decided if we put it in our proposal that if we were selected for Orion back in '06, we would build a spacecraft here at KSC in the ONC building. And so all of this work happening around the country all ends up here in Florida at KSC. So that's a very good thing. I talked about the booster being built, the Delta IV boosters. So the first one's showing up again next week. There's landing test out at Yuma for the parachutes. Ames is involved. You can see wind tunnel model here at Ames. Also arc jet testing on the heat shield. So the largest single piece heat shield ever fabricated. At the Lockheed Martin Sunnyvale facility, we did a series of two fairing separation tests, fairing deployment. I actually have a video of that. So this is a picture of the separation test, and I have a video of it here. So that was a big deal. We actually, on the first test, the fairings weren't quite as synchronized, so we had to make some changes, and then ran a second test that was successful. I need to get out of this and go to a different mode here to show this. This is the forward bay cover jettison test. Obviously, jettison of the forward bay cover is quite critical, because if you don't get it off, then you can't get the parachutes out, you can't land. So actually a series of 3 small chutes that come out and actually put tension on the forward bay cover, and then it has 3 large piston, gas generator fired pistons that fire to push it off. I put this in because, again, it's at our Sunnyvale facility, but if you look in the, kind of on the right-hand side of the slide, you'll see the ogive fairings that cover the crew module during ascent, and then the conical shaped ones above that, we call those the fillet panels. Those tie into the launch abort system on the forward end. So when we're sitting on the pad, you know, and you've probably seen, at least you can see the model next door, Orion is pretty much totally encapsulated. We have a hardware and software integration lab in Denver that, you know, we've run all of our ground and flight software through and bring out all of our test procedures. So that's been up and running for several years now. This is the primary structure for the heat shield. It was built in the Lockheed Martin Denver, Colorado facility. That's the substrate of the heat shield. It's a composite laminate layup that was done in Denver as well.
What is that, 5 meters, 7 meters?
Carbon?
It's no, it's just it gets TPS on top of it, ablative TPS. So I think the bond line temperature for the heat shield composite is around 400 degrees or 300 degrees max, I think. I'm sorry, what was your question?
Is that 5 meters across, or?
Orion is
5.02?
yeah, it's bigger than 5 meters. This is what the ONC building looked like about 3 years ago when we had just finished a major renovation, getting ready to accept the Orion hardware. And on the left, you see what it looks like today. In the foreground here is the EFT-1 service module. That's it on the right prior to fairing installation, or while we were installing the fairings, and then this is what it looks like today. It's pretty much complete. It's gone through a series of structural tests recently. The fairings are load-bearing during ascent, so we couldn't put it through its structural acceptance testing until the fairings were installed, which have to go on fairly late, because once you do that, you can't get to anything else, right? So we had to pretty much complete the service module before we did the structural testing. But it's now finished and it's waiting on the crew module. This is about 3 weeks old. It's changed a bit since then, but this is the EFT-1 crew module. Obviously, it doesn't have the back shell of the heat shield on yet, but all of the propulsion system has been installed. All of the active thermal control loops are installed. Most of the wiring is in now, and the inside looks pretty much the same. So I'd say the crew module is about 95% complete. It's undergoing a series of functional tests right now as we speak. When we're done with that, we'll put the heat shield on and the back shell panels, and then we'll go stack it on top of the service module, do some testing there. Then that stack will roll out of the ONC building around sometime in June. It'll go to the PHSF, which is a hazardous servicing facility at KSC, where we will load the ammonia and hydrazine and some helium. And then we'll roll over to a facility called the Launch Abort System Facility, where the EFT-1 LAS is now waiting on the CM-SM stack to show up. It's complete. the LAS is complete. That's where we will stack the LAS on top of the crew and service module, and then that'll roll out to pad 37 for integration onto the Delta IV.
What is LAS again?
The launcher board system,
Oh, yeah,
the
okay.
solid rocket launcher. We did initial power on testing a couple of months ago, so this is a picture of when that was taking place. This is the clean room cell inside the ONC building where we installed the propulsion and ECLIS systems, where we can acquire a 10K environment when necessary. We don't need that environment for long, but when we do need it, we can acquire it locally right there in the building. This is a better picture of the service module. So EFT-1 service module is not, I wouldn't call it high fidelity. Structurally, it's accurate. You know, it's keep in mind with the Europeans being involved now, so it's going to change quite a bit anyway. So this is kind of a unique configuration that will only fly this once. We are using, as I said earlier, we're using the Delta IV upper stage for our on-orbit propulsion. So, you know, we do not have a main propulsion system on Orion for this mission. The back shell panels, the conical section of the crew module, TP, the thermal protection system for that is shuttle tile or derivative of next generation shuttle tile. So all of the substrates for the back shell panels are at the ONC building, and we're bonding the tile on now for all of that.
Is that why,
This-
pardon me, is that why you have the cover for the shroud to protect those tiles?
Yeah, there was concern if you had to fire the abort motor, the acoustical environment raining down on the OML of the capsule was going to be detrimental and do damage. So we encapsulated it with the fairings exactly. And I think just the aero environments generally will be better with it encapsulated, right, than if it wasn't.
Do they have a camera to look out? They don't have any. They have no way of.
There's actually a hatch all the way through, right? Because in order to put people on, eventually you have to have a hatch all the way through those fairings,
Okay.
so they can see out that. But there'll be cameras as well.
Sure.
This is what the primary structure of the crew module looks like when it shows up at KSC. This is it's a aluminum orthogrid pattern. It's friction stir welded together. How many of you are familiar with that process? But if you're not, you should Google it because it's pretty interesting. It's not a plasma arc welding process. It's really more akin to machining than it is welding, but if you're interested. So that's done down at the Michoud facility where they built the external tanks for the shuttle program. This is the heat shield getting the TPS applied up at Textron Defense Systems outside of Boston. The heat shield TPS is an ablative type TPS, very much like the Apollo program had. In fact, when they went back to resurrect the recipe for the Apollo ablator, quite a few of the ingredients aren't available anymore and you cannot use because of their hazardous nature, so they had to kind of reformulate the recipe and run a lot of tests, but same type of thermal protection where the energy from the heat is literally cooking off the TPS. This is the heat shield arriving at KSC a couple months ago. They flew it in on the Guppy, the Super Guppy that NASA has. That was quite an event. This is the heat shield as it sits in the ONC building today. We're drilling the coordinated hole pattern in it so that we can bolt it to the underside of the crew module here in about 8 weeks. There's testing ongoing at the Neutral Buoyancy Lab. This is outside of Houston. You can see that's a representative forward bay cover. They're going to try and recover the forward bay cover. It's not a main test objective, but they are going to try and recover it off the coast of California, or EFT-1. MCC getting tied in Houston. The abort motor is poured at the ATK facility. I believe that's in Utah, I believe.
Never heard of that.
Is it? No? Where is it?
It's in Utah.
Is it? Okay. That's what I thought.
So I said,
Same
yeah,
time where they
I've heard
made
of
the
that.
solid boosters.
Yeah, it's the same facility they did that they poured the big boosters for the shuttle. The other two motors on the LAS, I don't think ATK makes. I think Aerojet makes the attitude control and the jettison motor, which are much smaller than this one, obviously. Langley is doing water impact testing, so they have a big big giant swimming pool, if you will, where they have a gantry. I'll show you a video of it, where they drop the capsule into the pool to do water impact tests. Let's see, this is the video. Yes. So they practice, you know, dropping different angles, coming in, different sea states. The capsule does have what's called a CMUS, or it's an uprighting system, up at the forward bay. This test article didn't have it, but it's basically, if you remember Apollo, you see the big beach balls on the front end. So that inflates after it lands to case it wanted to tip over, that would upright it. Okay. You can see them there. That's the CMUS uprighting system. So they've been doing some recovery testing. This is actually off the coast of Virginia in Norfolk. They just did another series of recovery tests out of Long Beach, I believe. The Navy obviously is involved. There's a Navy ship that has it's used for the big hovercraft that come in. It's got a well deck, so they're not going to quite do it the same way as Apollo, where the guys jumped in the water, they brought a raft up to the capsule and got them out through the hatch, brought them back to the ship, and then the ship picked up the capsule. In this case, they're going to literally tow the capsule into the well of the ship before they get the astronauts out. So that was it.
What's the atmosphere inside?
What is the atmosphere inside?
Is it pure oxygen? Is it?
Oh no, that's a good question. I mean, because EFT-1 doesn't have anybody in it, it's just, I don't know the composition of it, but it's just air.
Okay, but what about for the manned operations?
Yeah.
What's it designed to be?
That's a good question. I don't know. I'll have to follow up on that. Yes, sir.
What are the significant differences between CST-100 and Orion?
Well, I'm not that familiar with CST-100, but obviously our missions are quite different, right? I mean, they're
Actually, they look very similar.
right, but I mean, again, I don't know what their requirement set is, other than I know that they're to serve a space station, to bring people up and back to the space station. Obviously, we're designed for longer missions, and we have to keep people going alive for longer periods of time. So I would imagine that our onboard systems, especially those that are required to keep people alive, are probably larger, more comprehensive. I don't know, because I'm not familiar with the Boeing vehicle.
That's okay, there's not a lot available online about it either.
Well, they haven't won yet, right? I mean, they have a contract, but the big development contract is the one they're going to award this late summer or early fall. So I would imagine if they win, then you'll hear a lot about it, right?
I'm pulling for SpaceX.
Okay.
What's the size relative to the Apollo capsule? I mean, is it twice as big, or?
You know,
I mean,
I
it
should
doesn't
know that
look
number.
that-
I actually I've seen a slide where they have them scaled next to one another. I apologize, I don't know the exact percentage. I don't think it's twice as large, but it's close to being twice as large.
Yeah, I mean, for the longer space missions that they're talking about, that still doesn't look very big.
Well, keep in mind, you can go to the moon and back with just an Orion. If you want to go to Mars, you know, as I mentioned in Constellation Days, there was a vehicle called the Earth Departure Stage.
Mm-hmm.
So if you're going to go to Mars or something, you know, of that nature, that duration, there's going to have to be some other vehicle that Orion would hook up with in orbit in order to be able to sustain people for that length of time.
Sure.
I mean, it's Orion's, I think, main mission in that world is really to get you back, give them the vehicle to re-enter the atmosphere and bring you back safely.
Actually, a couple
questions. For that 130 metric ton model, which will be the Mars Orion version, are there any non-proprietary conceptual designs that are currently released by Lockheed?
Well, keep in mind, Lockheed doesn't own the launch vehicle development. SLS is, the prime contractor for SLS development is Boeing.
Not the SLS, the Orion capsule that will be sending the astronauts to Mars. Is there any non-proprietary concepts?
So
for
the
that?
the vehicle that's being developed right now, the EM, as I showed you, the EM-1 and EM-2 vehicles, those are the vehicle that will fly to any destination as of today. So there's not a different version of Orion that goes to Mars, say, versus to the moon. It's the same vehicle.
You'll just keep refurbishing it until it fails.
Well, no, it's not refurbishment. It's a new vehicle every flight.
Oh.
How is the radiation shielding research coming along?
Yeah. I don't know the answer to that, but I do know that I've been told that right now you're not going to survive a trip to Mars and back because of that. So there still has some work that has to be done in order to pull that off. I know that there are ongoing activities, looking at that research and development in that field, but I don't know where they're at. But I've heard that as of today, they don't. The problem obviously is, they can probably provide enough shielding, but the weight associated with that is what's going to kill you, right? So if you got to carry all that weight all the way to Mars and back, or anywhere past the radiation belts, your performance is going to be severely impacted, right? That's the problem, right?
Well, another problem with heavier shielding is secondary radiation when it gets hit by cosmic rays. So
that is a problem. Yeah. Yes, sir.
For the Orion capsule, what type of propellants will be used in its, I guess it's in-orbit rockets?
Yes, so
methane box or?
So the main engine on Orion, which this vehicle doesn't have, the EFT-1, but EM-1 will have, is the engine is a modified shuttle OMS engine. So what was the shuttle OMS fuel? Somebody in here, I'm sure, knows what shuttle OMS. No, I think it was hydrogen. I think it was a hydrogen. Yeah. Oh, because I remember it was hazardous, right?
No, it was hydrogen cryo, but it was oxygen hydrogen, the OMS engines.
But it was the cryo.
I thought it was hydrogen. Not the main engine. I'm talking about the
I'm talking about the
OMS.
OMS engines, just smaller pods.
I thought it was hydrazine because I remember them service. It was hazardous when they had to service them in a special building.
And they had to unload when it landed.
Right, I think it's. But so that's what the main engine on Orion will be, and then it's got RCS system. It's got a hydrazine monopropellant RCS system on the crew module and the service module.
Are there any alternative propellants being developed besides hydrazine? Because I know it's a very hazardous and toxic.
Yeah. Not for Orion, not that I know of. Keep in mind that because the ESA will now be providing that element to us, NASA is going to give the engine to ESA. They're going to integrate it into the module and then give it back to us.
How are you managing obsolescence on this thing, considering you're 7 years away from your real flight, and this thing's got a...
That's a problem, isn't it? I mean, it's the same thing the shuttle went through, right? I mean, the shuttle flew for, 30 years and had the similar problems, and then that's how it got so expensive to operate, or one of the reasons, right? Because all of the OEMs went out of business or said, I'm not interested in staying in business to supply you one component every 3 years. And so they ended up having to take a lot of that on themselves. So that's the problem if you only fly once every 2 years or so, is the fact that it's hard to keep a supply chain active and healthy if you're only flying once every 2 years.
The version of
I'm sorry, this guy. Go ahead.
Because Orion's designed to go beyond Earth orbit, there is no docking or interface to the space station possible?
That's correct. Today there isn't a space station docking capability because it's not one of our requirements. In Constellation days there was, and so you would think it could be put on, but it's not today.
Is the spacecraft designed with a docking tunnel of any kind?
Yes. Yeah. Now EFT-1 won't fly one because it doesn't dock to anything, but it will have a docking mechanism. JSC, NASA JSC's been developing a new docking system for as long as I can remember. It's called LIDS, I believe, L-I-D-S, that's the acronym. And so that's the docking mechanism that'll fly eventually on Orion.
In production, how many a year do you plan to build?
Well, right now, I mean, keep in mind, so all we are on contract for right now is to finish the DDT&E, which is the program I showed you with EM-1, AA-2, and EM-2. EM-2 being the first crewed flight. After that, you would go into some kind of production phase, and you know, right now the thought is once every 2 years. But it's all about how much money NASA can come up with, right, and how much the country wants to put people in space on those kind of missions.
Compared to EM-1, this flight test, what percentage of the subsystems in Orion are going to be up and running
Yeah, that's a
this
good
mission
question.
versus the first pull-up?
So on the crew module, everything is good to go. It's where we didn't put full-up flight systems on the crew module is anything that had a crew interface. So for instance, the displays that the astronauts would be touching, the touchscreen displays, we fly mass simulators for those. We don't have potable water, we don't have breathing air type systems, we don't have a potty or a galley. Anything that's crew interface is not high fidelity on EFT-1.
So
but everything else
is. So
is.
none of the ECLS systems are really...
The only ECLS system we're flying is the active thermal control loops, and even those aren't, they're not full up because they don't have to handle as much heat dissipation as a full up mission would. So the radiators on the service module, for instance, are just mass simulators. There's a small heat exchanger on the service module, but it's basically just for this flight.
So all the other subsystems are on schedule for 2017?
Yes. Yes.
What makes the SMS Orion system more affordable than the Constellation Orion system?
Yeah, I can't answer that because I didn't read the Augustine Commission's report in great detail. But Constellation, I think they had a more aggressive flight program, so they were flying more often. They had more elements, like I said, they had a lander. It was called Altair in development. They had an Earth departure stage in development. I say in development. They weren't issued to a contractor yet. NASA was still working on those. So it was a bigger program, but I don't know, to be honest with you. I mean, I don't know. I'm sure there were many reasons that the new administration felt like Constellation wasn't the right answer. You know, the official words from the Augustine Commission was that, like I said, while technically sound, you couldn't afford it with the projected NASA budgets in the out years. You couldn't afford to develop it. Why can you afford to develop this? I don't know. I mean, like I said, it has less elements, it has fewer elements, but you're going to need those other elements eventually. So if you want to go to the surface, you know, Orion doesn't go to the surface of Moon or go to the surface of Mars, just get you there. So you're still going to need a lander. And you're still going to need another vehicle to get you to some of those further destinations.
You said that the capsule itself has touch screens, so I assume that it's very upgradable from a software point of view. In other words, you could do changes.
Yeah,
we were talking about obsolescence, but you can do certain. I hate to use the word plug and play, but
yeah, I mean, I'm not a software engineer, but you know. You guys who've been involved in spacecraft development, anytime you go upgrade the software on the spacecraft or even the hardware is a huge block upgrade. I mean, you know, it's not going to be like you can just bring in a new laptop, plug it in, and you know what I mean? I mean, there'll have to be many ground tests run on, you know, the configuration of the software, et cetera. So, I mean, generally you would think that with today's technology, it's easier than it was, but still, I mean, it still goes through all the rigor of a human-rated spacecraft whenever you would change something like flight software.
Okay, in your opinion, why does it seem that NASA is so against the idea of a LEO fuel depot for deep space mission idea?
Yeah. Man, I'm buried in the, sure, I'm buried in the development of Orion. I don't know if NASA, does NASA have a big problem
just
with
seems
the
like
Leo
they
fuel? I don't even know if they do or
Because
they
that
don't.
idea has been around since Apollo era, yet it's never been tried.
I don't know why they would favor it or not favor it, to be honest with you. Sorry.
How far along was Lockheed Martin in terms of developing a service module before the decision was made to use the European
Yeah,
service module?
that's a good question. We were way, I mean, the design was finished.
Then why was it done? That's the question.
My understanding is that ESA had some, I don't know if you guys are familiar with the term offset credits between countries, you know? That's how we sell military things to foreign countries. I don't think any money really exchanged hands. It's just all book kept with offsets. I think ESA had some credits they owed the United States with respect to the space station program. And so one way to fulfill that was to get them involved in Orion and have them build and fund some of the hardware.
Has Lockheed ceased any kind of design on it, or?
Well, right now, the big push is to do all the work that it's going to take to integrate the European server. I mean, you can imagine it's a huge integration job now to bring this huge propulsion element in and put it together with your system, integrate the whole thing and have it work. So we stopped working on the Lockheed Martin version of the service module, and now we're working on integrating the ESA piece.
And long term, maybe you think there might be an option. I heard it's only for a couple of missions, and then maybe parts for the second.
Yeah, it's hard to say past EM-2 because I'm told that they're committed to two of them, quantity 2 for EM-1 and EM-2. Beyond EM-2, I'm not sure if they're going to provide it or we're going to build their version, or I don't know.
I heard parts. I heard someone say, well, they're going to have some components available.
Yeah, I don't know. That's a good question. But you know, if EM-2 does fly in 2020, we have a little while to get there, figure it out.
What does the spacecraft, what's the advantages, let's say, versus the SpaceX Red Dragon and Ice Dragon variants? How does it fare against, like, what makes Orion a better spacecraft?
Yeah, all I can say with respect to comparing us to the commercial guys, I really can't answer the question because I don't know what the other spacecraft are, what their performance is and how they're designed, and I don't know what their requirement set is other than I just know that they have to bring people to the space station and back. I don't know the details of those programs. I do want to comment that Orion is not in competition with the commercial guys. We have different missions. We actually are helping each other. I think that some of the landing, the parachute work that we've done on Orion has been offered to and given to some of the commercial guys to help them. So it's not an adversarial thing, it's a complementary thing. So
I guess what I'm trying to get to that is a lot of my coworkers over at KSC, the morale is very low. There's a lot of people saying, well, SpaceX will most likely probably take over the SLS Orion program and be the people to get astronauts to Mars, just because of the fact that it's with the whole political sense and the expenditures on both programs, it's just not really attractive. A 2-year launch doesn't seem very attractive nowadays.
yeah, well, you know, I can just tell you what the current contract that we have with NASA is for, and you know what our requirements are. You know, I think what will pace flying an Orion is really not an Orion spacecraft. It'll be an SLS. I mean, it's a massive rocket. It's the largest rocket ever developed by the country. It's bigger than Apollo, the Saturn V. So it's a massive system. I think if you got into a race and said how many Orions could you build, you'd probably have Orion sitting around waiting on SLS because it's such a big system.
The question is like asking which is better, Gemini or Apollo?
Yeah, it's different missions.
It's like asking which is better, Gemini or Apollo?
Yeah. Orion. So I'm certainly not. I'm not. I don't know because I don't know the details of the other spacecraft, to be honest with you. Anything else? I think we got to wrap it up. All right, I appreciate it. Thank you.